Hey everyone, we're back. And let's talk about our next topic. If you'll remember, I kind of mentioned earlier that there are certain things, issues that I see GIS newbies that they have problems with, and one of those was coordinate systems. And so that's what I'm going to talk about now. And in fact, I'm going to break this down into three parts. We're going to take our time. We're going to make sure that we understand this, because this is really, really important to understanding GIS, okay? So I want to talk about coordinate systems in general, but then we're going to focus on the GCS, or the Geographic Coordinate System, and then we're going to talk about projected systems at the end. All right, so let's get started. So you'll recall, I stressed this several times already, all GIS data is geo-referenced, which means it has a spatial component to it. And how do we know exactly where those data fit on the Earth? Well, we've got to have coordinates. We've got to have a coordinate system. And so a coordinate system is basically a way to find a point on Earth. Now, you're probably familiar with latitude, longitude, which is the basis for all coordinate systems. And we mentioned this already, but we're going to again reiterate it. Longitude are long. Longitude lines go north and south, and the latitudes go perpendicular to that. Latitude runs east and west. Consequently, if you're describing a set of coordinates for a point on Earth, the x-coordinate is the longitude value, and the y-coordinate is the latitude value. Okay? And this will become important later on when we work in the GIS, because we'll have to display XY coordinates, and we'll have to tell the software which one is the X coordinate and which one is the Y coordinate. And so you need to commit this to memory, or more importantly, if you understand latitude, longitude, you should be able to figure it out that longitude is always the X coordinate, latitude is always the Y coordinate. Okay. Well, this system is called the Geographic Coordinate System, or GCS. And it's the basis for all spatial reference. It works because this gives a point or a set of coordinates for every location on the planet. So anywhere you are on the planet, you can have a unique set of coordinates, and that's the power of the GCS, and that's why it is the baseline or the foundation for all other systems. We'll talk about other systems later, specifically projected systems, but they're all based on the GCS. All georeference data starts with the latitude, longitude coordinates. And you've seen these coordinates before. I don't know if you've ever thought about exactly why we do them, or we report them the way we report them. Whenever you get coordinates in the GCS, it's always so many degrees, so many minutes, so many seconds. And you think about it, well, why is it a degree? Well, it's because those coordinates describe an angle, right? And angles are reported in degrees. And we do things in angles because we're looking at a sphere, more or less. The Earth as a globe. And so anytime you work with circles or spheres, you have to talk about angles. So all GCS coordinates are reported in angles because they describe an angle on the Earth. And so this is a figure from your book that shows how these angles are defined. And so I've got a short animation here that I'm going to provide to you to help explain this a little further. Okay, if you study this figure, then you can better understand how latitude and longitude being expressed as an angle makes sense. So obviously we have the globe here with a section cut out, and we're looking at a point, say, right here. Of course, it works for any point on the globe. If you look at that point, let me get a pen here. So here's the point we're looking at. And if you drew a vector from that point to the center of the Earth, which is what this one is showing right here, and then there was another vector from the center of the Earth going out to the equator, you see that those make an angle. And so by measuring that angle, you're getting the latitude of this point. And by the same token, if you look at this point and imagine you're looking from above, say you're looking up here and you're looking straight down on the Earth, and you've got this same vector here. This vector here is in the same plane as this vector here. And if you're looking straight down, then this vector makes an angle with the prime meridian. So we draw a third vector here that connects the prime meridian, which runs through England. And if you're looking from above, you see that that will also make an angle in that way. And that's going to give us the longitude of this point. And so that's why the GCS describes an angle for the coordinates. Because with this system, any point on the globe can be described by these two angles. Okay, so study this picture, make sure you understand why the GCS system is reported or is based upon angles. Okay, now that we know what that is, let's talk about how we report those coordinates. And often those coordinates are reported as degrees, minutes, seconds, or DMS. And the minutes are similar to minutes in an hour. There are 60 minutes in 1 degree, just like there are 60 minutes in 1 hour, of course. And then there are 60 seconds in 1 minute. And again, a clock is a circle and the Earth is a sphere. That's why we're working with circular things. And so, as an example, there's a lake that I used to work on called Spring Lake. It's up by Macomb, Illinois. And its dam is at north 40 degrees, 30 minutes, 18 seconds. And the longitude is west 90 degrees, 43 minutes, 13 seconds. Excuse me, and you see that for minutes we have a single apostrophe, and for seconds we have a double apostrophe. And another way we could write those exact same coordinates would be 40 degrees, 30 minutes, 18 seconds, comma, negative 90 degrees, 43 minutes, 13 seconds. And so you see the difference here. North and east are considered positive, south and west are considered negative. So in the first set of coordinates, I specifically said it's north 40 degrees and west 90 degrees. In the second set of coordinates, I had a positive 40 degrees and a negative 90 degrees. And we automatically know positive 40 must be north and the negative 90 must be west. Okay? So, now that you know that, practice. Which of these two sets of coordinates is farther north? The left one or the right one? I'll give you a second. Make your guess. Okay, which one do you think it is? Well, it's the right one. You see that the right one is more positive, so it must be more north. The right one is north of the left one. Try it again with longitude. Make your guess. I'll wait. All right, which one did you guess, left or right? Again, it's the right one. Okay? So you see the right one is also more positive than the left one, right? And we're asking about which one is farther east. So east is positive. Which of these coordinates is more positive? Well, it's the one on the right. East is the one on the right is less negative, and west is negative. However you want to think about it. Okay, I just want you to be comfortable with these, and if I give you a set of coordinates, I want you to be able to figure out which one is more east, which one is more north, and so on. It just helps you understand how the system works. Okay. Now, another way that we can report coordinates in the GCS is as decimal degrees. All right, so it's the same coordinates, it's just a different way of reporting them. And so in the DMS format, here are the Spring Lakes coordinates, which I've already given you. The same coordinates in decimal degrees, the latitude would be 40.505. And the longitude would be negative 90.7. So you see the difference here. Instead of going degrees, minutes, and seconds, we just put it in terms of degrees only. And so we have the whole degrees and then a fraction of a degree. And so, for example, if you look at that latitude, the fraction of a degree is represented by 30 minutes, 18 seconds. And one way you can kind of wrap your brain around this is, okay, my fraction of a degree is 30 minutes, 18 seconds. I know that there's 60 minutes in a degree, but I have 30 minutes and some change. So my fraction of a degree is just a little over half a degree. You see what I'm saying? So if I look at that, the latitude coordinates here, I've got 40 degrees plus a little over a half a degree. And if you look at it, the version in decimal degrees, you see it's 40.505. 40 plus a little over half a degree. You see how that works? And you can kind of do the same thing with the longitude there. So this is a much simpler way to report your GCS coordinates. And I would encourage you to record your coordinates in this manner. And I'm going to require you to record your coordinates in this manner in this class. For one, you can see it's just simpler, right? You've got a single value, a single number for latitude and a single number for longitude. Whereas in DMS, you have to report 3 of them. This makes a big difference when you're, for example, storing things in a spreadsheet. With the DMS system, you've got to have a spreadsheet for degrees, a column for degrees, a column for minutes, a columns for seconds, for latitude, and then 3 more columns for longitude. Whereas if you have in the decimal degrees, you only need 1 column for each. So I think it's much easier to work with decimal degrees. Also, most GPS units, you can choose how it stores or reports your degrees, and you can go change the settings. And I would encourage you to change the settings to decimal degrees, just because it's easier, especially when you're working with GIS. But sometimes your GPS unit won't record in decimal degrees. Sometimes somebody will give you some coordinates and they're in degrees, minutes, seconds, and you need to convert them. So let's practice converting between the two. So to conceptualize this, first off, it's just like converting time, right? We've got 60 seconds in a minute, we've got 60 minutes in an hour. When we're talking about coordinates, we've got 60 seconds in a minute and 60 minutes in a degree. So in your brain, you can kind of think about this the same way. So let's say we're at work and we're clocking in, we're clocking out. We want to figure how much we're going to get paid. And we worked a little extra one day. So we worked 8 hours and 25 minutes, right? How much should I get paid at my hourly rate? We're not counting overtime here. And so you already know sort of automatically how to do this. You know, if you're getting paid, you understand how to do this math, right? You know that I worked 8 hours plus a fraction of an hour. I worked 8 hours plus 25 minutes. What fraction of an hour is that 25 minutes? Well, you know, 25 divided by 60 is 0.4167. So how much did I work today? I worked 8 hours and a fraction. I worked 8 hours, 8.4167 hours. So I should multiply that by my hourly rate, and that's how much I should get paid. So there I converted from, you know, hours and minutes to just decimal hours, right? So you probably never thought about this explicitly, but this is the same kind of logic and math you're going to use to convert in GCS coordinates. So here's a set of coordinates I'm going to give you, and I want to convert those to decimal degrees. So let me show you step by step, and then I'll let you practice. So here are those coordinates repeated again. And so I'm going to start with the latitude, and I've got 21 degrees plus a fraction of a degree, right? What represents the fraction of a degree? Well, 18 minutes, 25 seconds. That represents the fraction of a degree. So I'm going to start with the seconds. You want to start and work your way up 2 degrees. So I'm going to start with the smallest value, which is 25 seconds. That's a fraction of a minute, right? So how many minutes is 25 seconds? Well, again, you know how to do this. 25 divided by 60 is 0.4167. It's kind of like the math we just did, right? So I've got 18 minutes plus a fraction of a minute. What's my fraction of a minute? 0.4167. So I add those together, and I've got 18.4167 minutes. Right? But that's still minutes. We're still trying to convert that to degrees. So 18.4167 minutes is what fraction of a degree? Well, again, you know how to do this, right? You know there's 60 minutes in a degree. So now let's take this new number and divide it by 60. And that works out to 0.306 something something degrees, right? Now, that represents the fraction of degrees that I have in my coordinates. So I got 21 degrees plus a fraction of a degree. What's the fraction of the degree? It's 0.30694. So sum those together, and now I've converted the latitude to decimal degrees, 21.306. And again, in your brain, you can double check this, right? Because, you know, I got 21 degrees plus a fraction. What's my fraction? Well, it's 18 minutes, 18 some minutes, right? And you know, if you think in your head, you think, well, you know, 18 some minutes is not quite a third of a degree, right? Or if you're talking about time, you'd say 18 point some minutes is not quite a third of an hour. It doesn't matter, right? So my fraction of a degree here is not quite a third of a degree. When I do all the math, I check what I come up with. 21 plus 0.3 something something degrees. 21 plus not quite a third of a degree. See how that works? Okay. Well, now it's your turn to practice. So now you've got the longitude there. I'm going to pause, and I would like for you to pause the video and convert the longitude to decimal degrees and see if you get it right. Okay, we're unpaused. And so, what answer did you get? Let's see if you got the same answer I did. Again, we start with the smallest unit, which is 30 seconds. We know that that is a fraction of a minute. What's the fraction? 0.5. It's half a minute. So I got 51 minutes plus a half a minute. That's 51.5 minutes. But we still need to convert that to degrees. So again, we take that result, divide it by 60. And 51.5 minutes is 0.8583 degrees. That's our fraction of a degree. So I've got 157 plus a fraction of a degree, and my end result is 157.8583. All right? So did you get that right? I hope so. Now, if you don't like my way of doing it, I've placed another link on the Canvas page with somebody else's explanation for how to convert between these two. So hopefully between the two, you can get these straight in your brain. Now, ultimately, you're going to have these in a spreadsheet, and if you have a lot of these, you'll have the spreadsheet do it, but you still have to understand the formulas to get the numbers right. Now, we have our final coordinates, and those should be Honolulu, because that's where I picked coordinates that are landing in Honolulu. So I'm going to pause for a second. I'm going to take these coordinates, I'm going to put them into Google Maps, and I'm going to see if it's in Honolulu. Okay, let's select these coordinates and see where they show up, because it should be Honolulu. So you can just type them into Chrome, Google Maps, whatever, hit return, and this will pull up several links, but usually when you put the coordinates in like that, it's smart enough to know that you're looking for a map. So now we're going to go to Google Maps, and here's our point, and it does not look like Honolulu. Let's keep scrolling out. And we're in the Pacific Ocean, but we are not in Honolulu. So what went wrong? Okay, something's wrong. Because we took our coordinates, but they don't map to Honolulu, right? Where did we make our mistake? Well, if you remember that if you look at our coordinates up here, the longitude is west, right? So our longitude should be negative, and we did not report that as negative. So the correct coordinates should be 21 point something something something, comma, negative 157, all right? Now, when you're doing the math, don't worry about negative positive. Just do it the same way every time. And then at the end, if your coordinates are west or if your coordinates are south, you need to put that negative sign in front, okay? And so now I'm going to take these coordinates and I'm going to map them and show you that they are actually in Honolulu. Okay, so here we have the correct coordinates, which is negative 157.8583. This should be Honolulu. So I'm going to copy it. Now I'm already Google Maps. I can just paste it up here. Hit return. And we are in downtown Honolulu. So there you go. We just had the longitude incorrect because it was supposed to be negative because it's west. I'd like to point out, here's another way you can kind of check your math. If you look over here, we entered decimal degrees, but Google Maps changed it into degrees, minutes, seconds. And of course, this is a quick way that you could do this on your own, but understand that on the quizzes, I'm going to ask you to do this without using the internet. You're going to have to figure out how to do these conversions on your own. Okay, great. Now, like I said, I put a link on the Canvas page with somebody else explaining how to do this if you don't like the way I explained it. And I've also got a handout on there, and hopefully we're going to do some homework on this, and we're going to practice this until you really understand the concept. Okay, now, lately I've been noticing new instruments that have been reporting the GCS coordinates not in degrees, minutes, seconds, and not in decimal degrees, but in decimal degree minutes. No, degree decimal minutes. Thank you. There it is. All right. And specifically, I've been seeing this in a lot of the new fish finders. Because a lot of new fish finders, of course, they have GPS built into them. You can hit them to record a waypoint, or you can turn on a record function and it records every few seconds as you drive around. And then when you export those coordinates, they're saved as degrees, decimal, minutes. And many of the ones I've seen don't allow you to change this setting. We would like to change the setting to decimal degrees because that's what's easiest to work with, but in fact we are unable. So you also need to be able to convert things from degrees, decimal, minutes into decimal degrees, and vice versa. The thing is that it's the same math, it's just as easy. And all this is degrees with the minutes in decimal form. So all this is the same steps. You can just stop earlier than what we did in the last example. All right, we're going to work backwards this time, so I'm going to give you some decimal degrees. You tell me what are these coordinates if they were in degrees, decimal, minutes. I'm going to pause. Go ahead and pause the video. See if you can figure this out. Okay, so let's see if you got the answer correct. The latitude is 40 degrees north plus a fraction. So let's take that fraction and turn it into minutes. And so, whereas before we divided by 60, now we just times by 60. 0.505 times 60 is 30.3 minutes. So our latitude is 40 degrees, 30.3 minutes in this system. Just that simple. And your longitude, by the same logic, take the 0.72028 times 60 is 43 point something minutes. So our longitude is negative 90 degrees, 43.2168 minutes. Okay, so now that's pretty much the three ways you're going to see these coordinates reported, and you need to be comfortable converting between all of them as necessary. But like I said, most of the time I would recommend putting everything in decimal degrees. Now, as a final note on this, why are we seeing this now? Why are we seeing degrees, decimal, minutes? My guess is that it's the appropriate precision for the instrument. Like I said, I've been seeing this a lot on fish finders, and as you move around in your boat, you're unlikely to move so far that you change the degrees value, but you will change the decimal minutes value. Maybe that's why they do it that way. I think it might be, I don't know why, actually, tell you the truth, but I'm noticing it. So now you know what you know where you're going to find this, right? And you know how to convert it. Okay. Now, once we have coordinates, a lot of times we want to find where those coordinates fall on the Earth, or vice versa. We have a place on Earth and we want to know the coordinates. And of course, if you're standing in a place and you've got a GPS, that's how you get the coordinates. But a lot of times we're sitting at our desk, we're sitting at our computer, and we want to do these things. And so let me give you an example of how we can use these coordinates and see where they're at. So for example, here's a set of decimal degree coordinates. If we're in ArcMap, there's an XY tool. And you can just use this XY tool, type in these coordinates, and it will take you to that spot. Also, when you're in ArcMap, if you find a spot, you can figure out what the coordinates are just by using your mouse. So let's do this. Let me show you an example. First, here's some coordinates. Let me show you how to find this location in ArcMap. So here I have some coordinates in decimal degrees, and it's latitude, longitude, and I want to find where this point is using ArcMap. So I'm going to copy the latitude, and we go to ArcMap, and I have a map of Illinois because I know this is in Illinois, and I come up here. It's the Go to XY button. And notice here's longitude and latitude. Make sure that you paste your coordinates in the proper field. So there's my latitude. Come back. I'm going to copy my longitude and put it in this box. And then I have several options here. I can just make it flash. I can zoom to those coordinates. I can put a point at those coordinates. I can put a labeled point at those coordinates, and several other things. So I'm going to go ahead and make it flash. And you saw that, but of course it went away quickly. So I'm going to go ahead and add a point right there. And that's how you can use ArcMap to find the location of some coordinates you have. Okay, and now, like I said, we also often have a spot and we want to know what the coordinates are of that spot. And so there are many ways to do that. So I'm going to show you an example here where we're going to find the coordinates of the building that we're in right now. Okay, normally this is done in Blackburn. You may be wherever right now if you're taking the online version of the course. So when I say this building, I'm talking about Blackburn on the Murray State campus. So there are several ways you can find the coordinates of a particular location. As I mentioned, you can do it in ArcMap, but it's often easiest to do it in Google Maps. And you may be familiar with this, you maybe have already done this. So we can look it up in Google Maps and get the coordinates. Or, like I said, we can, if we're in ArcMap, we can just use our mouse to find coordinates. So now I'm going to show you how to use both of those techniques to find the coordinates of Blackburn Hall. Okay, first I want to find the coordinates of Blackburn Hall using Google Maps. And here I'm in Google Maps, I'm still at Honolulu. And I just need to find Blackburn Hall, so let's just say Blackburn Hall, Murray State University. And here's our campus, and I'm going to go ahead and turn on the satellite photo. And so then I need to zoom in a little bit. And this building is Blackburn Hall. And so I want to find the coordinates. So I'm going to pick a corner of the building here, anywhere I want. I'm just going to pick the corner. I'll pick we're going to pick the corner where the lab is. And I'm going to right click and choose what's here. And you see down here at the bottom, it's very faint, but there are the coordinates of that point in latitude, longitude. And so I can click on that and it just centers that point, but then up here in the left I have those actual coordinates. So that's how easy it is to find coordinates using Google Maps. Now let's go over to ArcMap, and here I've got a project, and you recognize Kentucky, and here is a point that I already made, that's Blackburn Hall, so we know where it is. I'm going to zoom in, so here's the zoom in button. I'm going to draw a little rectangle around it so I can zoom in. And so if I have a point like this and I want to know what the coordinates are of that point, I can just take the little arrow here and put it on that point. And if you look down here in the lower right, you see it's giving me the coordinates of the cursor. And watch, I'm going to move the cursor around and you see how those coordinates change. And of course it's in decimal degrees. And so that's how I can find the coordinates of a point using ArcMap as well. Okay, so now you know how to report GCS coordinates, you know how to convert between them, you know how to find the coordinates of a location, you know how to, if you've got coordinates, how to find where that place is. We're going to be doing this all semester, so keep practicing. And that is all I have for this first part. And now in the next parts, we're going to get into some of the details about each of these systems so that you can understand them. And we're going to talk about how ArcMap works with these coordinate systems. So stay tuned, come back later. I've got a part 2 of this GIS lecture coming up soon. See ya.